All right, let's look at our inverse trig functions. So I'm going to start with sine, and to have an inverse, a function needs to pass the vertical or the horizontal line test, and the sine function would not work. And it is true for all periodic functions, which is all of our trig functions are periodic. So what we have to do is we actually have to limit the domain of our sine. We're just going to take one tiny little section, and just that part will have an actual inverse. Okay, so when we do the inverse here, graphically that looks like reflecting it across the axis of symmetry, which is the line y equals x. And now we have a new function, which is the inverse of sine. And we talk about that, when we talk about it, we use the word arcsine. So that means the inverse of sine. And just a little note, just be careful. It can look confusing because if we're talking about a reciprocal function, that would be if we had sine of x to the power of -1. That's a reciprocal, and that's different than what I'm talking about. Okay. I am talking about the inverse itself. So it just is a little bit confusing because we would write them with a -1. But if we're talking about the arcsine, which is the inverse, the -1 is between the sine and the x. Let's do some examples. First, sine. All right, so for me it's helpful always just to always kind of go back to the unit circle, and just when we're doing arcsine, we're only looking at quadrants 1 and 4. Okay, so here's our first one, arcsine of 1. Well, let's see, what does that equal to? The relationship between sine and arcsine is that the sine of some number is equal, the output is equal to 1. And so I would just go and look to see where is my output 1, which is right here. And then the answer will be what's the x value that would create that output, and that is at pi over 2. All right, this one is saying what the sine of what number has an output of 1/2. All right, I go in and I look, where do I have an output of 1/2, which is right here. And so my answer is, it is the angle, the t value, that gives that output. All right, and now here, this one does not exist because you can go through, the highest output for y is only 1. There is no t value, there's no angle that would give an output of 2. Okay, moving on, let's do a few more. So let's see, I'm trying to figure out sine of what angle has an output of -√3 over 2. So let's see, -√3 over 2. Remember that sine is the y value. And so here x is the angle 5 pi over 3. All right, what happens when we take the arcsine of sine? Okay, so kind of taking this step by step, let's go in and figure out what would the sine of 0 be. And angle of 0 has an output of 0. So then we're taking the arcsine of 0, and remember what that means. Sine of what angle equals 0? Ooh, that's 0. Okay, because we kind of went backwards. So these just cancel each other out, and we're just left with the 0. All right, and so inverse, just as a little reminder, what does inverse mean? Like, these are the ones that undo each other, right? So if I had x squared, what's the inverse is square root. So if I had x plus 2, what's the opposite of that is subtracting. So that's the same thing. They undo each other, and you're just left with 0. Let's see, here, sine of pi, that is 0. Now, we're kind of on the wrong place over here. Arcsine is only defined on, quadrant 1 and 4 of the unit circle. However, sine itself, sine has an output. what's the sine of pi? The y value right here, that is 0. Okay, so we can evaluate sine. That's just 0. So now we're taking the arcsine of 0. Okay, now we go to 0 and figure out what is the output there. 0. So these can be a tiny bit confusing. Just take it step by step. Let's just do in here. What's the arcsine of root 2 over 2? That is pi over 4. What's the sine of pi over 4? Root 2 over 2. All right, what's the arcsine of pi? There is none, because arcsine is really a limited function. It's only defined between negative pi over 2 and pi over 2. So this does not exist. And you can't take the sine of something that does not exist. Let's look at our inverse cosine function. In this one, we're going to limit just to quadrants 1 and 2 in the unit circle. So we're just going between 0 and pi for our arc cosine function. So here, if I'm trying to figure this out, arc cosine of 1, that means cosine of x is equal to 1. Okay, so what angle has an output in cosine of 1? And that is the angle of 0. Okay, so here, who has an output of 1/2? Well, that one is the angle pi over 3. Okay, this one does not exist. There is no output that's greater than 1. There's no angle that would create an output there of 2. So that one doesn't work. Okay, here we're looking for an output of negative root 2 over 2, and that corresponds to the angle 3 pi over 4. Okay, let's move on. So here, cosine of 2 pi. Well, that's not in the correct section of the graph for arcsine, but here what we're doing is first we're taking the cosine of 2 pi. Well, I can take the cosine of 2 pi. That just gets me over here. The output there is 1. So this would be the arc cosine of 1, because this is really a composite function. So first we're doing cosine 2 pi, evaluated that, we got 1, done. Arc cosine of 1, well, we just figured that out right up here. That is 0. All right, so here, this is just going to cancel out. It's just going to undo itself. We're going to be left with 2.68, because that canceling property, it works if we're between 0 and pi, and 2.68 is less than pi. Pi is about 3.14. All right, how about here? Does this just undo itself? Cancel out? It does, because root 2 over 2 is within the correct section of the graph. Okay, so that is just root 2 over 2. All right, now does arc cosine of 2, can we evaluate that? No, we just figured that out. That does not exist. So the whole problem doesn't work, doesn't exist. So for the tangent function, this is a little bit different. This is the one where there's asymptotes at pi over 2 and negative pi over 2. And then it sweeps up like this, but then it continues. There's another one and another one back here. So this certainly does not pass the horizontal line test. So what we're going to do is just limit our tangent function just to this little section in here. So we're just going between negative pi over 2 and pi over 2. And then we will have a inverse function right in there. Okay, so let's go through and do some of these. I've put in here, just as a reminder, those tangent values on the quadrant of the unit circle. Okay, so what is the tangent of what angle has an output of 1? That is at pi over 4. oops, pi over 4. Right here. All right, here, which angle has an output of root 3? That is pi over 3. Okay, moving on. Who has an output of -1? Right here, and that it corresponds to negative pi over 4. There we go. Okay, so here, tangent of 2 pi. Well, that's certainly not in our section of graph right in here. However, if I went and just did a quick little reminder of the unit circle. Okay, so 2 pi. Well, that's the same point as 0. And so we can take the, the tangent there, that's 0, and then you can take the arc tan of 0. And the output for that, the arctan of 0 is 0. And then on this one, you can do that on your calculator. You'll just get approximately negative 0.46. Okay, and the idea here, if we looked at where we are at 2.68, so what's the reference angle there? Pi minus 2.68, that is 0.46, but we're looking at which, a place which is defined for the for arc tangent, and that is at this angle at negative 0.46. All right, so that's kind of why that one works. Here, this next one, the canceling properties will work here, and the output is just root 2 over 2. And likewise here, the output is just 2. Our canceling properties work on that one as well. All right, so there's our inverse trig functions for sine, cosine, and tangent. And it really does help just to have your unit circle. Just print that out, have that in front of you, because it can really make these problems so much easier to figure out.